What's up guys, another redox video, this time combining half equations. Much simpler than the half equation stuff, but super important anyway. Before we get into it, please like, subscribe, share. Let's get into it. So here, combining half equations, we obviously get a full equation, right? The thing to remember here is we never have electrons in these. So no electrons. So we need to balance these in such a way that we cancel the electrons out, all right? Which means obviously we're not going to be able to combine these two equations, for example, because these two equations, the electrons are both on the right-hand side. And so there's no way we can combine them in order to cancel them out. The only thing we could do is if this was a reversible reaction, we could swap the products and reactants around. But for now, let's just combine let's just combine them in the right way. So if we've got 1, 2 and 3, let's start off by combining 1 and 2. So first things first, what we need to think about is how many of each we need, right? So here again, we're thinking about cancelling these electrons. So if we've got 6 electrons to cancel out on the left, we also need 6 electrons on the right. So what we need to do here is we need to times this equation by 3. Now, next step, very simple. We write all of the reactants. So we've got 3H2O, because we've times everything by 3, plus 6 VO2. And now we write all of the reactants for reaction 2 as well. Plus 6E minus, plus 6H plus, plus Fe2O3, makes, and now we do all of our reactants, all of our products, sorry. So there we've got 3 lots of the V2O5 plus 6 lots of the H plus 6 lots of E minus, and then for the other one plus 2 Fe plus 3H2O. So we've combined them, we've multiplied out to make sure the electrons cancel. We've written all of our reactants, we've written all of our products. Now we need to cancel things. So we look at what cancels. We know, because we've manufactured it so, that our electrons cancel. That's great. Now we need to see if anything else matches up. Okay, that's interesting. Our waters match up, they cancel. Next, our H pluses cancel as well. So now we rewrite it with everything else cancelled. So we've got 6 VO2 plus Fe2O3 makes 3 V2O5 plus 2 Fe. And that's our full equation. And let's do the same. This time let's do 2 and 3. Let me move this out of the way a little bit. So this time we've got 2 plus 3. Here. For number 2, I have 6 electrons. Number 3, I have 10 electrons. Okay, that's a little bit harder to cancel these electrons. We need to find the sort of lowest common factor. That's clearly going to be 30, isn't it? So I need to multiply everything here by 3. And number 2, I need to multiply everything by 5. And now I do what I did before. So I'm combining all of my reactants first. So I have 30 E minus plus 30 6H plus 30 H plus, sorry, plus 5 Fe2O3 with 18 H2O plus 3 Cl2. Then we've got our products, so we have 10 Fe plus 15 H2O, 6 Cl3, ClO3 minus, sorry, plus 36H plus 30 minus. Now I do the same thing. I'm cancelling everything I can out. We know straight away our electrons are going to cancel. I've got 30H plus here. I've got 36 there, so I've got 6H plus left. Waters, I've got 18 here, 15 here. So I've got 3 H2O left. And now I can rewrite this. So I have 5 Fe2O3 plus 3 H2O plus 3 Cl2 makes 10 Fe plus 6 ClO3 minus plus 6H plus. Now these are about as difficult as these questions get. Often they're a bit easier, but good to try some more difficult ones initially. Same thing here. So we've got 1, 2, 3. If we combine 1 and 3, and then 2 and 3 as well. And I'll answer that at the end of next video. For now, let's try and do these. So, first of all, balance the atoms. 2 IO minus. Remember, this is from the end of last video. Next, balance the oxygens. Plus 2 H2O plus 4H plus. And we've got 2 minuses, 4 plus, so plus 2E minus. Next, let's bring this down a bit. Copper's already balanced, let's add our water, plus H2O, plus 2H plus, plus 2E minus. Nice, last one. Here, we need 2 V's there, plus 4H2O to balance the oxygens, plus 8H plus 8E minus to balance. Hope that's helpful. Next time we're going to look at redox in terms of definitions. We'll also look at a slightly newer term. Until then, happy revising.